Welcome to this explainer. You know, if you've ever wondered how clinical psychologists actually know that a therapy cures something like depression, and they aren't just sitting in a chair, nodding and guessing, well, you are absolutely in the right place. Today, we're diving into a masterclass on how the field moves way beyond mere description to scientifically prove that therapies actually alleviate human suffering. Our goal today? We are going to teach you exactly how to think like a top-tier clinical researcher. To get us there, here's our game plan. We're taking 6 distinct steps to build an airtight case for evaluating psychological treatments. We'll start with the quest for causality, unpack the experimental toolkit, look at real-world flexibility, learn how to defend against validity threats, touch on ethics and data, and finally, wrap it up with evidence-based practice. So let's jump right in. Starting us off with part 1, the quest for causality. Literally every single day, therapists face a massive detective problem. Imagine you've just invented a brand new therapy. Let's say it's a highly specialized treatment for severe insomnia. A patient comes in, receives your therapy, and then they start sleeping better. Great, right? But how do you truly, undeniably know your treatment was the actual cause of their improvement? Could they have just gotten better on their own? Well, let's look at how we actually design research to answer that. Okay, so we really have 2 main approaches here. Correlational designs are great for finding links, like, say, noticing that people with high stress tend to sleep less. But here's the catch. They cannot prove cause. To prove your new sleep therapy actually caused the cure, you need the absolute epitome of the scientific method, which is the experimental design. By using manipulation and randomization, experiments give us the power to rule out alternative explanations and confidently establish a true cause and effect relationship. Which brings us to part 2, the experimental toolkit. Let's step inside the lab for a second. A true experiment basically relies on 3 foundational pillars. First up is manipulation, meaning you explicitly decide who gets your new sleep therapy. Second is control. You have to attempt to hold all other extraneous factors constant, making sure both groups have the exact same room temperature, the same caffeine intake, all of that. And third, randomization. You randomly assign patients to different groups so they are perfectly comparable before you even begin the test. Enter the independent variable, or the IV. You can think of the IV as our primary suspect in this detective case. It's the specific factor that we are manipulating. In our running example, the independent variable is your new sleep therapy, being compared against, say, a standard relaxation technique. Now, the crucial point is this. If the IV is the cause, the dependent variable, or DV, is the effect. This is the hard evidence. For our sleep study, the DV wouldn't just be casually asking a patient, hey, do you feel better? It would be the measurable, quantifiable number of hours the patient actually slept. We're looking to see exactly how manipulating the independent variable changes the dependent variable. And you know, we have some brilliant ways to set this up. A between subjects design compares entirely different groups of people, like those getting your sleep therapy versus a waitlist control group. A within subjects design repeatedly tests the exact same people under different conditions. Factorial designs let us test interacting combinations of variables, and single-case experimental designs meticulously track one individual's baseline before, during, and after a treatment is introduced. It's like a giant puzzle we get to piece together. Moving right along to part 3, real-world research flexibility. So, as we all know, human lives are messy, right? We definitely don't always get to work in a perfect, pristine lab. And this is exactly where quasi-experimental designs come in. They still utilize manipulation, sure, but they do not involve random assignment to conditions. Why? Well, because sometimes randomization is just completely unethical or even geographically impossible. If you want to compare 2 different already established healthcare clinics, you can't just randomly swap their patients around. You have to test them as they are. These designs are highly cost-effective, but we have to keep in mind that without that randomization, outside influences might sneak in. This actually brilliantly illustrates a massive distinction in clinical psychology: efficacy versus effectiveness. Efficacy research represents the highly controlled lab environment. It proves your sleep therapy can work under perfect conditions. But effectiveness asks a tougher question. Does it survive contact with reality? Does it still work in a noisy, chaotic, real-world clinic with typical patients and typical therapists? As you can imagine, both are absolutely critical to the teaching and practice of clinical psychology. Next up, part 4, defending against validity threats. Okay, so once we have our data, our job isn't done. We have to fiercely defend it against threats to validity. Basically, alternative suspects that might have caused the cure. For instance, did a patient sleep improve because of your therapy, or just because the weather cooled down? We call that history. Or maybe their extreme insomnia just naturally normalized over time. That's called regression to the mean. We also have to guard against people naturally maturing, dropping out of the study, or reacting differently simply because they know they're being tested. A truly robust experimental design successfully rules every single one of these out. Let's look at Part 5, Ethics and Data Analysis. Long before a treatment ever reaches the public, we have a strict ethical obligation. Participants aren't just data points on a spreadsheet. This means obtaining true, informed consent, ensuring the potential benefits heavily outweigh any risks of harm, and maintaining ironclad confidentiality. And hey, if we ever have to use deception for the sake of the science, it must be highly justified and followed immediately by a completely transparent debriefing. We have to vigorously teach and enforce these standards. With that ethical data in hand, it's time to run the math. We use statistics like t-tests and ANOVAs to ensure our results weren't just a lucky fluke. We also calculate effect size, so we can standardize and compare our success with studies happening all over the world. But honestly, the ultimate test is clinical significance. We don't just care about the spreadsheet math. We have to ask, did this intervention actually make a meaningful, noticeable improvement in a real human being's daily life? Finally, Part 6, Evidence-Based Clinical Practice. This brings us to the ultimate goal of everything we've talked about, evidence-based practice, or EBP. Modern therapy isn't just about sitting in a room and guessing what might help. It requires professionals to synthesize this rigorous experimental research with their own clinical expertise, all while tailoring it to the unique, complex human sitting right in front of them. It's an ethical responsibility to use the most scientifically validated tools available to us. You've now seen how clinical psychology moves from simple hunches to hard, rigorous science. We know how to establish causality, how to defend against alternative threats, and how to properly run the numbers. So, as we wrap up this explainer, I want to leave you with a provocative thought. You now know exactly how to gather the undeniable data. But as you look forward in this field, how will you take that rigorous evidence and use it to actually change a life?